Okay, so today we're gonna be going over basic counting, so what you have to do and tips with basic counting. So, um, we're gonna have an introduction to like what counting is, then counting tips, so like counting from A to B and off by one errors, etc. We're gonna do some practice problems, and we would actually do a Kahoot, but it has a cap to the number of people, so I'm not sure if we'll be able to. But we can always try. Um, So, you probably know how to count. But basically we count by small quantities in our lives, right? So like, how many classes are you taking right now? In your head, you can count. Honestly, put the number of classes you're taking in the chat, you know? Um, yeah. But you should be able to count small amounts, like how many classes are you taking and how many siblings do you have? So after schools would probably not count as classes unless you are getting a grade. Um,
Okay, Tej, I found out how to do it. Tej, I found
so
out.
so wait, sorry. Okay, I don't know if someone was saying something. But okay, so we would be able to count our classes, how many siblings we have, etc. Right? So I have eight classes, or yeah, eight classes, and I have one sibling, right? So I'm able to count small amounts, and you probably are able to also. However, when we have a lot of things to count, we likely don't know how to count them, right? So, how many strands of hair are there on your head? Or how many cards are there in the world? Or anything really, but like how many stars are there in the universe? In theory, both of these quantities can be counted, um, but it's too tedious for us to do, and our accuracy would drop. So, um if you okay, when you see a difficult problem in math, you should be able to change it so it becomes easy. So we are actually going to change counting for larger amounts so that it is easy for us to do. Okay, so Ruth, if you
Okay,
want
so here they're asking you to count the number of numbers that you see. Okay. So people are saying 7,
no, that is for
6,
their class.
and over 1 billion. Oh, okay, okay.
Yeah,
Yeah,
it's
there's 5 numbers.
yeah.
And then next, how many numbers are there in that? So there are 24 numbers, and the 3 dots that are shown after the 4 are called an ellipses. And so all you really have to do, since it starts with 1 and it counts by 1, all you really have to do is look at the last number, which is 24. And so next, how many numbers are there? Okay, so a lot of people are saying 7. And so here you can just count the numbers, or you can also do 10 minus 4 plus 1, which will be 7. Now count the number of numbers here. Okay, yeah. There are 86 numbers, and this is similar to the last one, where it will be 90 minus 5 plus 1, which will get you to 86. And another way to do it is to subtract 4 from each number, so that way you can just start from 1 and go up to 86. And so that would be called an off by 1 error. Well, this one is off by 4. But basically, off by one errors means that every number is off by a certain number. So in this one, every number is off by 4. So if you subtract 90 minus 5, you get an answer of 85. It seems reasonable, but if we do this, we are leaving one number out. Consider 1, 2, 3, 4, and 5. We know that there are 5 numbers, but 5 minus 1 is actually only 4.
Yeah.
So that's why when you do 90 minus 5, you have to add 1 to it.
Yeah. So yeah, and off by one error is basically where you over subtract, and that causes you to not actually count the number of numbers that there are. So now we're gonna do a bit of a harder, or not a bit harder, but okay, count the number of numbers of these. Okay. Yeah, I'm seeing quite a few 4s, and there are 4 numbers. Yeah, so here you would not want to do like 20 minus 5, which is what you might have done earlier for like 1 to 24, right? Or and then added 1, or like 5 to 24 or something, right? You might have done 24 minus 5 to count the number of numbers, but that's not something you would do here. So okay, so if we were to do see the number of numbers from 3 to 36, if we're doing multiples of 3, how many numbers are there? So try to use like whatever you've used for previous like patterns, right? So we basically try to scale it down to a number pattern from 1 to any other number, right? That's above 1. And then we would count. So what would we do here? Okay, so I'm seeing quite a few answers. I'll actually give you all another minute. Okay, so there are a lot of 12s and 13s. So you might have been able to guess, but only one of those answers is right, right? So when I said earlier, we want to scale it down to a number pattern that's from 1 to something, what I meant is like we would subtract or we would divide to get something where we're skip counting by ones, right? So if we divide all the numbers here by 3, right, then we'd be able to get 1, 2, 3, all the way to 12, right? So if we count the number of numbers from 1 to 12, we get 12 numbers, right? So it would be 36 divided by 3, not 36 divided by 12. Because if we divided all the numbers here by 12, we would get 1/4, 1/2, 2, or 3/4, 1, and that's not counting by 1, right? So yeah. Okay, so that is basically how we got 12, right? So there are 12 numbers. If we divide by 3, we get okay, yeah, let's not judge, right? We will all make mistakes. It's not that big a deal. Okay, 7, 11, 15, all the way to 87, 91. Okay, so how many numbers are here? Okay, they probably got 13 because of the off by 1 error right earlier, where people will either overcount by 1 or undercount by 1. That's
Yeah, no, yeah, that's what I was asking. Like, did you add 1 like last time? Or
that's probably what they did to get 13. So yeah. Okay. I'm curious as to how all of you are getting 13. Okay. So basically, okay. So remember what I said earlier about we want to scale it down to a to a succession of numbers that's like 1, 2, 3, 4, 5, right? So in order to do that, first what we're going to look is at the difference between numbers, right? So we would be adding 4 each time in order to get to the next number. So that means that we want to make this first number 4 times 1, the second one number 4 times 2, the second number 4 times 3, and so on, and then divide by 4, right? Because if the common difference is 4, right, we can see through all of these that it would be 4. The common difference would be 4. That would mean in order to scale it down to like 1, 2, 3, 4, 5, 6, 7, and so on, we would want to be able to divide by the common difference, right? So when we subtract um, 3 from each number, we would get 4, 8, sorry, 4, 8, 4, 8, 12, right? And so on, all the way up to 84, and then 88, right? So now we have a succession of numbers that it's divisible by 4. We can see that in each of these numbers, they are divisible by 4. So when we divide each of these numbers by 4, we would be able to get 1, 2, 3, all the way to, 1, 2, 3, all the way up to 22 when we divide by 4. So that would mean that the number of numbers is 22, not 13, as you all were saying. So I am still curious as to how all of you got the wrong answer. Okay. Well, okay, maybe you all thought that it started at 7, it ended at 7 times 13, and then divided by 7. Although that's not gonna work, like if you did 1 to 20, right? Each of the numbers, or like 5 to 20 as like 5, 6, 7, 8, 9, 10, whatever, you divided all the numbers by 5. Technically, you would start at 1 and you'd end at 4, but that's not 4 numbers, right? So like you have to also look at the common difference. So this leads us to the fundamental counting principle. Okay.
Okay, so if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. So for example, if I have 8 shirts and 4 pairs of pants, how many unique outfits can I make? Okay, so a lot of people are saying 32, and that's right. Since 8 times 4 is 32, that means you can make 32 outfits because there are 4 ways you can. There's like 4 options for shirts and 4 options for pants. So then that would be 8 times 4 is 32.
Okay.
Okay, another example. If I now have 6 sweaters and 3 skirts and 4 necklaces, how many outfits can I make? Okay, the answer is 72 because 6 times 3 times 4 is 72. And it doesn't matter how many different things, you just have to multiply all the numbers you have when you're trying to figure out how many different ways you can make a unique combination.
Okay, we're gonna do a little bit of practice with both of the concepts we learned, right? So counting, like and off by 1 errors, and then with the fundamental counting principle. So how many numbers are in this following list? So remember what we did was we first scaled it down to a 1, 2, 3, 4, 5, 6, 7, blah, blah, blah progression, right? So you'd want to do that here. And then, yeah. Okay. I'll give you all like 5 minutes for this problem. So 736. Okay, if you don't get this, remember what we did earlier. We tried to scale it down to a 1, 2, 3, 4, 5, 6, 7, whatever progression, right? So what we would first do is we would find the common ratio, right? Or the common difference that we're adding to get from one number to the next. And then we subtract however much from the first number we need to get that common ratio as that first number. And then we divide by the common ratio. So we get 1, 2, 3, whatever, right? And I'll write this down when we solve this problem. So what would really help is after each step you do to like or not transform, but like to scale this sequence, what would help is if you would write out what the sequence is. So if you're adding like 1/3 to every number or something, right? If you wrote down like 4, 4 and 2/3, 5 and 1/3, 6, so on, right? Until 27 and 1/3, right? You can write the dot, 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 the ellipses, right? But if you did that, that would be very helpful in seeing if you're actually getting like 1, 2, 3, so on, right? Okay, so I am going to start explaining this. So what we would do is first, okay, so there are a lot of ways we could do this, honestly, as long as we're getting to the 1, 2, 3, so on progression, right? So what I would do is I would first convert these to improper fractions, right? So this is equal to 11/3, right? Because 3 is equal to 9/3, and then 2/3 plus 9/3 is equal to 11/3, and then 4 and 1/3 is equal to 13/3, right? Okay, it's equal to 13/3. 5 is equal to 15/3, right? And we continue all the way to 27, which is equal to 81/3, right? So we get a set of fractions that looks like this. So next we could look at the common fraction, or the common, difference, or we could honestly multiply everything by 3. So we just get like whole number progression, right? So I'm gonna multiply everything by 3. So we get 11, 13, 15, all the way to 81. So we get this as our progression. So what I would do now is I would look at the common difference. So we're adding 2 between each number, right? So plus 2, right? So and then whatever numbers before this will also be plus 2. So that means that I want to get this first number to be equal to 2. So that would mean I would subtract 9, right? So if I subtract 9 from all numbers, right, I would be able to get 2, 4, 6, all the way until 70, all the way until 72. Yeah. And when we get 72, because 81 minus 9, yeah, 81 minus 9 is 72. I don't know why yeah, okay. So we get 2, 4, 6, so on until 72. So now, because everything here is just divisible by 2, we can divide everything by 2. So dividing everything by 2 gets us to it gets us to 1, 2, 3, all the way until 36. So that would mean that we are counting how many numbers are there from 1 to 36. That would mean our answer is 36. So that's how we would get that as our answer. So I see some of you got 35. So I'm assuming you either subtracted 9 incorrectly from 81, or you when you were doing this, you only did to like this number, or you subtracted 1 for no reason. Which, like, if you don't have a reasoning for why you're doing a step in your problem, then just don't do this step, right? If you don't know why it's contributing to the problem, it probably is not, right? It's probably just something you are not remembering correctly as something to do, right? So just don't do something if you don't know why you're doing it. So yeah, we would subtract 2. So yeah, this is just how we would do it. We'd get 1 to 36 as our progression of numbers. So good job to everyone. But some of you did get 40 or 71. I'm kind of unsure of how you got that. So if that's your answer, do you understand how the answer is 36?
So why don't you like subtract 10 from 11 and like everything else instead of like only subtracting 9?
Okay, so if we did subtract 10 from 11, we would get 1. Okay, if we did, we'd get 1, 3, 5, all the way until 71, right? And technically, you could find the number of numbers in this progression, but we wouldn't be able to do it by dividing by 2, right? We would have to do something else, right? Like we would have to count the number of, like in order to count the numbers from 1, 3, 5, all the way to 71, it would be much harder than just dividing by 2, right? Because after that, I just add 1 and then divide by 2, which is equivalent to subtracting 9.
Yeah.
Yeah. Okay. Everyone else who did not get the correct answer, do you understand why the answer should be 36? Okay. Okay. And by the way, if we did want to express this as a formula, where the first number, okay, if we did want to express how many numbers are in a list, where A is the first number, B is the last number, and D is the common difference, right? Then what we would do is we would do, okay, so we would subtract, okay, so hold on. Then we would do A, okay, B minus A, which would in this case be equal to, okay, 23 1/3. Okay, so we would, if we did want to, okay, so honestly speaking, if you did want to do this as a formula and remember that, you likely are not going to be remembering the reasoning behind your steps, and you'd be able to mess up pretty easily. So yeah, but B minus A over D plus 1 should be the formula for this case. Although you do not want to memorize the formula, you should want to memorize like the logic, right? Like what exactly you're doing. Okay.
Okay, so Sandra Bullock's birthday is on July 26th, and her friend Canoe's Reeves' birthday is September 2nd. Each year, Sandra and Canoe celebrate by eating a cake every day from Sandra's birthday through Canoe's birthday, including both birthdays. If they did this for the first time in 2008, how many cake eating days will they both have observed at the end of 2016? So, I'll give you until 7:50 for this one.
Okay. So I feel like you all have a couple off by one errors from what you have said in the chat. Because, okay, so first we're going to look at the number of years since that's what we want to count first, right? Okay, if we were to look from 2018 to 2016, right? If we were to subtract 2007 from each of them, we would get 1 all the way to 9, right? That is 9 years, right? So that means that if you got 8 years by looking at 2008, like 2016 minus 2008, that is wrong. Okay, so now we multiply that by the amount of days per year, right? So let's start in July, right? So we have July 26th all the way to 31st, right? So that's 26, 27, 28, 29, 30, 31, right? So that's 6 days in July. Right, so I'm gonna write 6 and then July. And then in August, there are 31 days, right? It would not be 10 years. Okay, because when we subtract 2007 from both numbers, it's 1 to 9. Okay, and then 31 is August, and then September is just the 1st and 2nd, which is 2 days. So we have 6, 31, and 2. So when we add 6, 31, and 2, we get 39, right? 39 times 9 is what we have to do, right? So 39 times 9 is equal to 351. So you would get 351 days. Let me look at the answers. Okay, some of y'all said 324. You multiplied by 8, I think, right? Or you did 38 times 9. I'm not entirely sure what you did, but yeah. Okay, if you did 38 times 8, you have an off by 1 error for both the years and the days, right? Which results in you being kind of far off, right? And then 351, I feel like a lot of you got that. Okay, so yeah. Do you all know why it is 351? Like, do you understand? Okay. Okay, that is good. Okay. Okay, this is likely our last problem. Joe wants to find all the 4-letter words to begin that begin and end with the same letter. How many combinations satisfy this property? Okay, do you all have any questions about the previous problem? Because you're still typing about it in the chat. Okay, if not, you can do this problem. Okay, so quite a few of you have answers, right? So I will start explaining, right? So I'm first just gonna draw little blanks to show like the 4 letters, right? So we have 4 spaces for 4 letters. So we can have any letter for the first one, right? We can have 26 different letters for the first one, right? But now we know that that the last letter also has to be this, right? So that means that for each of them, we only have one number or one letter that it can be, right? So if we choose A for the first letter, it has to be A for the last letter, right? And now we have 26. Like we have no restrictions on the second or third like letters, so we can just multiply. We have 26 different things, right? So now we multiply each of these out, right? Because fundamental accounting principle, right? Where we would multiply the total number of possibilities for each to get the actual value, right? So we get 26 times 26 times 26 times 1, and this is equal to 17,576 combinations, right? So I see some of you said that in the chat. I think some of you multiplied by 3, or not 3. You multiplied by something else. We multiplied by 1 in order to get, because we know we want it to begin and end with the same letter. So that means we have only one possibility for that last letter if we've already chosen the first letter. So does that make sense? Yeah. Okay. Okay. So it would be the same without the 1, but we just want to show that we are accounting for the fact that it has to begin and end with the same letter. Right? Because we have 4 different letters. We just want to it's not necessarily a formula, but yes. Yeah. Okay. I'm assuming the O's in the chat mean that you are having something click, which is good. Yeah, the middle letters also count. Wait, okay. Yes, we account for the middle letters when we're multiplying, if that's what you mean. Like there are different possibilities for those middle letters. Okay. Yeah. Then yes. Okay. So yeah, we would have 17,576 words. Let us not scribble. Yeah. Okay. We will not have time for another problem. However, we will be posting these slides so you can go through and try to solve the remaining problem, right? And you can honestly look at the Kahoot to see what problems there are, so you can solve those if you have free time or anything. So yeah, I will